In this video, we look at analysis of variance, or ANOVA for short. ANOVA is an extremely important technique because it is used in scientific research to analyze data from controlled experiments. It allows you to test cause and effect relationships, which is crucial to building theories about cause and effect. ANOVA tests the difference in the mean value of a dependent variable y across two or more groups. The null hypothesis is that the means are all equal, and the alternative is that one or more means are different across groups. If the groups are based on an independent variable x, ANOVA can be used to analyze the effect of x on the dependent variable y. For example, x may be price, so you may have groups of consumers that are exposed to different prices, and y may be sales to those consumers. ANOVA will allow you to test whether price had any effect on sales. As I mentioned earlier, ANOVA allows you to test cause and effect relationships where x is the cause and y is the effect. It can be used in any field of study, not just marketing. In fact, originally, ANOVA was used in agriculture to study the effects of various factors on crop yields. In order for ANOVA to be appropriate, the independent variable x has to be categorical and the dependent variable y has to be quantitative. An ANOVA with only one x is called a one-way or one-factor ANOVA. If there are two x's, it is called a two-way or two-factor ANOVA, and so on. In this class, we will look only at one-way ANOVA. Let's take an example of how one would run an ANOVA using SPSS. Let's say the data consisted of two variables, sales, which is a metric variable, and a categorical variable group representing the groups of consumers exposed to different price levels. In this example, there are three groups, each exposed to a different price level. We will use ANOVA to determine the impact of price on sales. In SPSS, the grouping variable is called a factor. To run the ANOVA, click on Analyze, Compare Means, One-Way ANOVA. Define the dependent variable, which is sales. Define the factor, which here is group. Click Options and check Descriptive. Click Continue and OK. The results of the ANOVA are shown in the table labeled ANOVA. The last column shows the p-value for the test of the null hypothesis that the groups are equal. You can see that the p-value is less than 0.05, so we can reject the hypothesis and conclude that the means are not equal. The descriptives table on top shows that Group 1 had the highest mean sales, followed by Group 2. That would be the takeaway from this analysis.